Hey guys, tonight we're going to work with matrices, and this time we're going to work with something called Cramer's rule. Now, what Cramer's rule lets us, what it does is it lets us solve for the variable, and that's what we're going to, instead of doing like all that stuff that we were doing in class, the row reduction and all that stuff. So let's just solve for the variables, and this is what Cramer's rule does. It says this: x equals the determinant dx over the regular determinant, the determinant for x over d, regular determinant. The y is dy over d, and z is dz over d, or whatever letter they're using. It doesn't matter. So let's take a look at what does this mean. All right. So let's start with a problem we actually did in class. And the problem that we did in class was, what was it? X minus y plus 2z equals negative 3. And 2x plus y minus z equals 0. Negative x plus 2y minus 3z equals 7. All right, so this is a system of equations. So this is called system of equations. And what we're going to do is we're going to take this system of equations and put it into a matrix. So my matrix would be, and we're going to do the coefficients, right? So it'll be 1, 2, negative 1, negative 1, 1, 2. What's that? 2, negative 1, negative 3. 2, negative 1, negative 3. So that would be the matrix of the coefficients. And then we do this, just like we did in class, I showed you, x, y, z. And that would equal the answers, negative 3, 0, and 7. So this is what it looks like in matrix form. Well, let's do this. All right, so first I'll find the regular determinant. All right, that's the regular part. So the determinant. Now, just like in the other video, what we did in class, so 1, 2, negative 1, negative 1, 1, 2, 2, negative 1, negative 3. Now the only problem is I don't have enough of the downs. So I got enough columns. So what I got to do is I'm going to copy over the first two columns. So 1, 2, negative 1, negative 1, 1, and 2. And if you recall, what we did was we did downs minus ups, downs minus ups. So it's like this, downs minus the ups. So 1, 1, negative 3 would be negative 3. Negative 1, negative 1, negative 1 is negative 1. 2 times 2 times 2 is 8. So when you just combine those, we get 4. And now we're going to do the up. Okay, so these are the ups. So negative 1, 1, and 2 is negative 2. 2, negative 1, 1, negative 2 again. And negative 3, 2, and negative 1 is positive 6. So 6 minus 4 equals 2. And remember, it's downs minus ups. And we're going to do a lot of this for these problems. So it's 4 minus 2 equals 2. That's regular determinant. That's D for the original setup. Well, let's find the dx, the determinant for the x. All right, so this is what you're going to do. It's a little weird, but you got to buy into it. We take the first column, and what we're going to do is we're going to switch it out with the answers. So I'm going to take the answers and put it into the first column, because that's going to be the x's. So I put that in the problem. And then I just copy over the regular stuff like we did before. So negative. And so that's what I'm going to find the determinant of right there, that part. So that's what I'm working with. So it's a little weird. It's a little weird. Okay. Now once again, I don't have enough. So negative 3, 0, 7, negative 1, 1, 2. So I need those extra parts. I'm actually not going to draw the lines this time. I'm just going to look at it and just do it. So -3, 1, -3 is +9. -7, +7. 2, 0, 2, that's a 0. Clean that up, and I get a 16. Let's do the other one, the ups. 7, 1, and 2 is 14. 2, 1, and 3 is 6. Negative is +6. -1, 0, and a -3 is 0. Clean that up. We get 20. So now remember this, downs minus ups. So 16 minus 20 equals -4. That is dx. So now we do what the formula says. Now the formula said this, x equals the determinant for the x, which in this case is -4, over the determinant for the original problem, which is 2. So when I do this problem, I clean it up, I get -2. That's the x value. So let's try it again. So dy. This time we swap out the y column with the answers. That would be in the middle. So -3, 0, 7. And I fill in the normals. 1, 2, -1. And the 2, -1, -3. Once again, 1, 2, -1, -3, 0, 7. And just nice and easy. Just go through it. Right. 0, -3. 2, 2, 7 is 4, 7 is 28. Clean that up. We get 25 for the downs. Ups. 0. 7, -1, that's -7. 9, +2, and that's 18. Clean that up. -7, 18 is 11. So 25 minus 11 is 14. That is dy. So y equals dy, 14 divided by 2. And the y value is 7. Do it again for dz. Okay, for now for the dz. So I copied down the original. Let's use black. So I copied down the original. So 1, 2, -1. And -1, 1, 2. This time I swap out the third column. -3, 0, 7. This is before the dz. And I need those extra columns. 1, 2, -1, -1, 1, 2. 7, 0, so -12. -5. Do the ups. 3, 0, -14. That gives me -11. So now downs minus up. So -5 minus -11 equals 6. That's dz. So z equals 6 divided by 2 equals 3. So for this problem, the x, y, and z would be x is -2, y is 7, z is +3. Let's try it again. Okay, so this was another problem we did in class. So question 2, I don't know if I labeled question 1, but it's all right. Question 2, x minus 2y plus z equals 8. 2x plus y minus 3z equals -9. -3x plus y plus 3z equals 5. So that's my equations. And you have to remember, Cramer's rule says this: x equals dx over d, y is dy over d, and z is dz over d. So the first thing is get d. All right, so d. So I'm going to use the original. So 1, 2, negative 3, negative 2, 1, 1, 1, negative 3, 3. So go ahead, find the determinant. Hit pause, whatever, find the determinant. So hopefully you came up with d equals 5. So downs minus ups, downs minus ups. So let me help you get set up here. All right, so now we're going to do dx. Okay, so dx, I'm going to swap out the first column with the answers. So it'll be 8, negative 9, 5, and keep the other two columns the way they were. And while we're at it, might as well set up dz, dy, excuse me. So I'm going to swap out the middle column. And put the 1, 2, negative 3 back. 1, negative 3, 3. And might as well do dz. Just set them all up. Swap the third with the answers. And put the first two back the way they were. 1, 2, negative 3. All right, so find the determinants for each. Hit pause. Go. All right, so I found the discriminants for all the pieces. So I got dx equals 10. The determinant, excuse me. The determinant for dy is negative 5. And determinant is, what do we got over here? 20 for dz. So now we're going to go through and do our little rule. So x equals dx over d. So it's 10 over 5. So the x value for this problem is 2. Y is dy over d. So it's negative 5 over 5, negative 1. And finally, z dz over. So it's 20 divided by 5. We get 4. So the answers are 2, negative 1, and 4. Well, hope that was okay, and I'll see you tomorrow. Thanks. Bye.